So next is diagonalization of symmetric matrices, that is orthogonal transformation. So next, diagonalization of symmetric. Symmetric matrix is whose transpose is the matrix itself. So for this question, 2, 1, minus 1, 1, 1, minus 2, minus 1, minus 2, 1. So this is a symmetric matrix. We have to diagonalize this matrix. Diagonalization means we have to convert this A into a matrix D such that D is equal to Q transpose AQ. Q is the matrix of transformation. It is a matrix in which the eigenvectors are, or normalized eigenvectors are the column vectors. And we get this product Q transpose into A into Q gives D. D is a diagonal matrix whose diagonal elements will be the eigenvalues. Okay, so for this matrix, and this is clearly a symmetric matrix, then what is its characteristic equation? It is lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. s1 is sum of the diagonal elements, that is 2 plus 1 plus 1, it is 4. And s2 is sum of the minors of the diagonal elements, that is first diagonal is 2, minor of 2 is deleting the row and column containing this 2 and find the subdeterminant. So 1 minus 2 minus 2, 1. Then next diagonal 1, its minor is delete the row and column containing this 1. So 2 minus 1 minus 1, 1. Then next diagonal 1, so it is 2, 1, 1, 1. Then evaluating we get it as minus 1. Then S3 is determinant of A, that is minus 4. Okay. Next characteristic equation is lambda cube minus 4 lambda square minus lambda plus 4 is equal to 0. And we have to solve this equation. We can solve using calculator easily. Okay. Or otherwise without calculator we can factorize this from the two terms. Lambda square as common. So lambda square to lambda minus 4. Minus of lambda minus 4 0, or lambda minus 4 is a common term. So lambda minus 4 into lambda square minus 1. So either lambda minus 4 0 or lambda square minus 1 0. If lambda minus 4 0, lambda is 4. Lambda square minus 1 0, lambda square 1, or lambda is square root of 1. It is plus or minus 1. So there are three eigenvalues, lambda, 1, minus 1 and 4. Okay. Next we have to find eigenvectors for these three eigenvalues. First of all, for lambda is equal to 1. So A minus lambda into x is equal to 0 implies subtract 1 from the diagonals, and this is a homogeneous system. So column vector, eigenvector x1, x2, x3. We need to find x1, x2, x3. So it is 1, 1, minus 1, 1, 0, minus 2, minus 1, minus 2, 0. Then by taking the first two rows, this method, cross multiplication method, x1 by, delete the first column, so 1 minus 1, 0 minus 2. Then minus x2 by, delete the second column, so first and third. Then x3 by first and second. So this gives x1 by minus 2, x2 by minus 1, minus x2 by minus 1, x3 by minus 1, or minus 2, this minus becomes its plus, so minus 1. So minus 2, 1, minus 1 is the first eigenvector. Because it is a column vector, I write it as row transpose. Okay. So next one for lambda minus 1. If lambda is minus 1, subtract minus 1 from the diagonals or add plus 1. Okay. So we get this matrix. Again x1 by, we are taking the first two rows. So x1 by second and third column minus x2 by first and third column, x3 by first and second column. So we get 0, minus 5, 5 in the denominator. Second term minus 5 becomes plus 5. E negative positive akum. So 0, 5, 5 is the second eigenvector, or we can divide throughout by 5, or it is 0, 1, 1. It's a column vector, so row transpose. Again lambda 4. So in this case 4, subtract 4 from the diagonals, and x1 by, okay, minus 5, minus 5, 5, or it is, we can divide by minus 5, or it is 1, 1, minus 1. So this is a third eigenvector. So which are the eigenvectors? Eigenvectors are minus 2, 1, minus 1, 0, 1, 1 and 1, 1, minus 1. And then we need to find the normalized eigenvectors. Normalized eigenvectors means we have to divide the vector by its norm or modulus. What is its modulus? Modulus of a vector is square root of sum of squares of the components, or root of x1 square plus x2 square plus x3 square. Same as modulus, but here we call it as norm. Norm, norm. So normalized eigenvectors are minus 2 by, here what is the norm? Root of 2 square, that is 4 plus 1 plus 1. 4 plus 1 plus 1, 6, so root 6. So divide root 6 with every terms. Then second one 0, 1, 1. So 1 plus 1, 2, root 2. Third one 1, 1, 1. Upper 1 plus 1 plus 1, 3, root 3. So divide by 3, root 3. So write these eigenvectors, normalized eigenvectors as column vectors, we get Q. So this is the matrix of transformation. And the diagonal matrix D is Q transpose AQ. So this is the transpose of Q, this is the given matrix and Q. So the product is 1, 0, 0, 0 minus 1, 0, 0, 0, 4. This is the diagonal matrix. Okay, just we need to write the product at least first and second terms, second matrix. Okay.